Okay, we're back on this. I want to take this as a little learning experiment here because I started to close off the vacuum source, and because I wanted to let the vacuum stabilize out. Because think of vacuum like water. Air is a fluid. Just like water is a fluid, milk is a fluid. When you have liquid metal, it's a fluid. It follows the same principles of fluid dynamics. Stuff you learned in grammar school, or at least high school and junior college. So it's under vacuum. I have the valve depressed right now. It's drawing a vacuum. Now it's going down here. It's at 2022 microns, and it's going down by tenths. You can see the decimal point. I'm going to unscrew and disconnect the vacuum source from the system. Now the vacuum over at this point is lower than the vacuum way over here at the high side, because we got a mile of pipe, and we have an orifice tube, accumulator, and we have a evaporator in between this point to this point. So think of it as a bucket of water right here and a bucket of water over here, and we have a water pump. We have a hose attached at the bottom of the two buckets. Imagine this. And so when you remove water out of this bucket, the water can go down and flow through the small little tube at the bottom of the bucket and kind of fill this bucket over here. So you have a water pump pumping out water faster than the water can transfer through a very, very small tube from one to the other. Same thing is happening within vacuum inside this system. So now watch what I'm going to do. I'm going to disconnect this, and what you're going to see is after I remove the vacuum from the system, this vacuum number is going to keep falling. Because on this side of the bucket is still high, full of water. On that side of the bucket, under the deeper vacuum, it's at a lower pressure. And so the higher pressure wants to flow through the small tubes over to the lower pressure. So it still will be leaving this side of the system, flowing over, say that big accumulator and the evaporator that are under a lower pressure. It'll still be flowing in that direction, and we will be able to read that on the meter. So here I go. Look at that, 1940 is the vacuum rating. I'm disconnecting it right there. There I go. It's now disconnected. There's no more vacuum being applied. But look at the number. It's still going down. Because the vacuum on that half of the system is lower than this half. The water on that bucket is lower than the water in this bucket. And it's still slowly going over there. And there'll come a time of equilibrium when both sides are even. And you'll be able to read that when this stops going down. Then you know the vacuum on this side, on the high side, is equal to the vacuum on the low side. And we're not going to stand here and watch water or grass grow. And so I'm going to put this back on. I'll get back to you guys. Oh, one more note. As you can see, remember, here's a refrigerant hose right here I'm using for vacuum. Here is a 3/4 inch silicone vacuum hose that is just meant for vacuum only. This is what you should be using to draw vacuums in, not refrigerant hoses. And another note, here's another learning lesson for education. Okay.
Not necessarily.
So let's turn that off. Let me open it. HVAC School Vortex by Tex on podcasts. On any podcasting streaming app, look for HVAC School Vortex by Tex. If you want to know, here they're talking about liquid quality and versus subcooling, and they have many topics about subcooling and superheat. They talk about residential air conditioning, which is medium temp, and freezers, refrigeration, that is low temp stuff, and they operate differently. They talk about the same things, but you cannot take them one for one and apply one industry to another industry. There's basic simple principles that mean certain things that do not apply to each other under certain circumstances. So this is a great educational source, but you have to remember when you're talking about refrigeration, you do not apply some of that knowledge towards air conditioning that's a medium temp. And you have to know the difference between an accumulator system and a receiver system, and what do or don't have these different components. But excellent source of education right here. HVAC School, Vortex, Vitex podcast. They're also on YouTube too, so you could watch videos by them. So let me click out here. As you can see, this is still falling even though the vacuum is off. There's no vacuum, but the numbers are still falling because the molecules of moisture and air are still traveling over to that lower pressure. Just like heat travels to cold, moisture travels to dry, high pressure travels to low pressure, and like electricity, high potential energy goes to low potential energy with electricity. Everything wants to equalize. All right, catch you guys later.